All right. And we're off. Okay. So, when your denominator is a binomial and nothing squared, you cannot use Pythagorean identities. At that point, you must multiply by the conjugate. You don't really have choices. All right. And when we multiply by the conjugate, we have 1 minus sine x over 1 minus sine squared x. If you just remember that, those of you that are concerned about this quiz, you're going to get half the points. Because you're understanding how to simplify using a conjugate. Now is where knowledge comes in. By Pythagorean identities that you need to know tonight, you need to know what 1 minus sine squared x is equivalent to. And that, my friends, is cosine squared x. Good? At that point, the advantage for us is the denominator is now a monomial, which means either in your head or on paper, you can write both terms separately.
No, but can I tell you stories about him? No? Okay.
Not right now because it's being recorded.
Oh, you really?
Yeah, I am. So I can put it on Google Classroom. It's so quicker.
Okay, I have a question for you.
That is fine.
The basketball game tomorrow, are they meeting early to practice or anything else?
No. No.
What time is showing up at?
I'm going to get back to you on that one. Truett told me 6:15. I don't care. As long as the game starts at 6:30. If you roll in with your entourage at 6:25, that's fine.
I'm gonna stay after practice and shoot around for a while. Like,
yes. I'm assuming it's like 6:15, but I'm going to go talk to my fellow teammate and advising about that.
should I ask her?
No, I can.
Who's coaching? Like, who's making calls? Who's starting? Am I a starter?
If you want to be.
No. Connor, Ron.
All right. Now, once you have it, think of everything in terms of sine, cosine, secant, cosecant. In other words, what is the reciprocal of cosine? And we're going to talk about this in a second. Secant squared x. Everybody okay with that? So that's secant squared x. The challenge we have is working with that, and I think this is where we are having issues. All right? So my suggestion to you is once you get to here, and a lot of this quiz is about following directions. Cosine squared x is secant squared x right away. So instead of going through all this and making your life harder, you can take that expression and say cosine squared x is secant squared x. So that'd be secant squared x 1 minus sine x. Now remember your directions. Your directions were to simply state, rewrite it so that it is not a fraction. Have I rewritten it and is it not a fraction? Right. I'm done. Now, if we have a second example, for example, tangent x over sine x. Now they're monomial. My suggestion to you, it doesn't have to be done this way, is the first thing you do is rewrite it as a division problem. rewrite it as a division problem. Then we write everything in terms of two things: sine and cosine. So in other words, as we progress, and this is going to be huge, everything can get rewritten as sine and cosine. Everything. Sine, cosine, obviously. Secant, the inverse of cosine, 1 over cosine. Cosecant, 1 over sine. And by using quotient identities, we can rewrite tangent x as sine x over cosine x. You've known since the beginning of time the division of fractions indeed involves multiplication. And what can I then do with that sine x? Rewrite it as 1 over sine x, because that's what division involves. What do the sine x's then do to each other? Cancel out. Once they do, what are you left with? 1 over cosine x. And 1 over cosine x is equivalent to secant x. You got it. See? Quiz isn't going to be that bad. It might be. Because it's a binomial. See what I mean? When there's two terms in the denominator, you got to do, and we're going to go through different things in a second that you handle, you got to recognize. So what this lesson is about is recognizing things. Because the hardest thing in this unit, in my experience of teaching it for the last few years, is people don't know when to do what. Okay? Now, I will tell you this. If you have secant to the x, secant squared x minus 4 over secant x plus 2. Secant squared x minus 4 over secant x plus 2. As soon as you don't see what number that's involved in all Pythagorean identities. 1. If we get that, and all your Pythagorean identities that you should now have a copy of, 1's involved in all. As soon as you don't see 1, you're going to factor. Alright? The top, secant squared x minus 4, is a difference of 2 squares. So it factors into that. And what then do the secant x plus 2 do to each other? Cancel out. And you're left with just secant x plus 2. And you're done. It's simplified, and it's written as not a fraction. Yes, sir. Knick-knack. Yeah, that's what it is. You guys can teach the rest of the class. I'm done. Even the people that show up later smarter than me. What? What do you mean number 8? From the review a half an hour ago? Cosine squared x. Thanks for catching up. Appreciate the effort. So when you have to rewrite so that it's not a fraction, you get an idea. Okay, now, let's start talking about what to remember. All right, what to remember. So, okay, one thing is obviously the Pythagorean identities. And hopefully it's ingrained in your head. Sine squared plus cosine squared, whatever variable they give you, is equal to 1. And from day 1, we talked about the need to rewrite. So in other words, if it's 1 minus cosine squared, you have to be able to recognize that that's sine squared. If it's sine squared minus 1, you have to be able to recognize that that's the negative of cosine squared. There's no ways around it. Now, the rest of this discussion is centered around codes. And they are huge. Not cosine, codes. Because that covers a lot of stuff. For example, cosecant of pi over 2 minus x. Does cosecant have a co or does it not have a co? Has one. So you drop it. And if I drop the cosecant if I drop the co from cosecant, what do I have? Secant x. So I would expect you to see if I have cosecant pi over 2 minus x. Alright? Times cosine x. For example, cosecant of pi over 2 then is the secant x times cosine x. So now you got half the point. Then I would expect you to recognize that secant is 1 over what? Cosine times cosine x. And then what do the cosine x's do to each other? And leaves you with 1. That's the difference between 100 and not 100. Being able to do that. Okay? The other reason codes are huge is they help us with the reciprocal identities. They help us with the reciprocal identities. So in other words, 1 over sine x is cosecant x. So with your reciprocals, 1 always has the co, 1 does not. Much like the sine squared plus cosine squared is 1. Hopefully it's pretty straightforward for you to know that tangent and what are reciprocal to each other. Cotangent. These are the exact same thing with the co. Well, that means if you look at sine, does sine have a co? No. That means the reciprocal sine is cosecant. Same thing, does cosine have the co? Yes, so it's reciprocal secant. This also helps you with the remaining 2 Pythagorean identities. Because with Pythagorean identities, the co's stick together and the non-co's do not. So 1 plus tangent squared is secant squared. 1 plus cotangent squared is cosecant squared. Now, I personally know that those two are always greater than or equal to 1. I know that from the beginning of the year. That's how you know those should be the ones that are always going to what? Stand all by themselves. So when you walk in tomorrow, and some of you do this, and kudos to you, some of you, the first thing you're going to do is what? Write down all your identities. They're not being given to you. You have to know those when you come in. So that's the idea, to make things easier for you to remember for that moment that you jot everything down. Okay? So, yes, I will be after today.